Simple rules for differentiation. The objective of this lesson is to recognize when to apply the power rule and to find the derivative of a function, apply the power rule to find the derivative function, find the derivative of an exponential function ex, and apply the linear rules of basic rules of derivatives. So in the last video we talked about what a derivative is, right? So the two main things we want to think about in this class is slope of a tangent line. So if I give you a graph like this, you could find that if I want the derivative at a point like 3 here, what you do is you go up there, draw a little tangent line. That's not bad. And then you find the slope of it, right? Using rise over run. That's one what we did last class. We did the slope of a tangent line. Also means the derivative also means instantaneous rate of change, and also means like limit of a difference quotient. That's when we did this formula. The limit as h approaches 0 of f of x plus h minus f of x all over h. Right. So those are the two ways to do the derivative. In this lesson, we're going to show you the easy ways to do it. Now, before we do that, let's talk about all the different ways we could take a derivative. So let y equal f of x be a function, and let a be a constant. Right, so if you see this notation, f prime of x, that means take a derivative. Right, f prime of a, that means take a derivative and plug the value a in. A lot of times I'll say, I'll say the function y. A lot of times I'll say y prime. That also means derivative. Right, if you see y prime with a, that means take the derivative, plug a in. Right, these all are just symbols for take a derivative. The more fancy symbols, derivative of y with respect to x. So the little WRT here is with respect to. With respect to. That's just talking about what variable you're talking about. So I'm going to take a derivative of a function like y equals 3x squared plus 4 with respect to x. So we're talking about taking derivative of x there. So the derivative of y with respect to x, the way it's written. This is the same thing, but now afterwards you plug in your value for x. So you take a derivative, plug in x. And then this could go for any function, right? Derivative of f with respect to x. I could put derivative of y, derivative of z, whatever, with respect to x. So all these things all mean the same thing. So if you see any of those, it means take the freaking derivative. Note by itself, if you see d of dx, that doesn't mean as a fraction, this means take a derivative. That's all it means. Right, so that's the thing. dy dx is a derivative function, blah, blah, blah. So like this is a derivative function, like that's an actual derivative. This says take the derivative. Slight difference there, right? They're saying, hey, the derivative of your answer is this. This says, hey, do the derivative. So let's actually go with the actual power rule. So here's the power rule, also known as the easy way to take a basic derivative. So if I give you a function xn, the power rule is simply bring the power down and subtract 1 off. Like that. So if I give you x squared, from it, the derivative, if that's y, the derivative that's going to be, bring the 2 down, subtract 1 off. Like that. And if you actually look back through the work, I don't have it here, but every time we took a derivative, that's all it was. The answer was always just bring the power down, subtract 1 off. I know, I hear you guys getting mad. It's a process. We have to learn the hard way. Anyway, warning, this does not apply to this, right? So notice how this has a function inside of it. This is a composition of functions, this f of gx stuff you guys love so much. The power rule doesn't apply for that. We're actually going to talk about that. It's one of my favorite rules of calculus. And that actually is my favorite rule of calculus. But we'll talk about that in a future lesson. So we're still working with basic ones right now, because this is not a power rule. So this is our first one. Given f of x equals x cubed, find f prime of x, then find f prime of 2. Right? So first let's apply our power rule. So the derivative of this, f prime of x, we're just going to bring down the power and subtract 1 off. So 3x squared. Now they want f prime of 2. Look how easy that derivative was, by the way. So easy. Now let's plug in 2. So that's all that means. So 3, 2 squared. Know our algebra, we do this first. So that's 4. And 4 times 3 is 12. So that's it. Right? That's the slope of the tangent line of this function at 2. That's instantaneous rate of change at 2. That's our derivative at 2. So that's a basic power rule. The easy way to take a derivative of the power. Again, notice it only works for functions, for power functions, right? X to the n powers. So we're not talking about e to the n. We're not talking about other things. We're not talking about this. Right? That's not a power function. Power function is only something with the base of x and the power of a constant. So let's talk about some other easy rules while we're at it. So first one, it's a kind of constant rule. What if I give you the function is y equals 3? Well, the derivative of that is just 0. Always. If I give you a constant, the derivative of that is always just going to be 0. Lots of ways why is this true. One way, if you just look at the graph, right, y equals k. That's my x, my y. I know, such a pretty graph. Let's say it's k or 2, right? Remember, it's a horizontal line, and the slope of a horizontal line is 0. So that's one reason why it's true. You can also think about it this way. Y equals 3, x to the 0 power. If you bring down the 0, you get 0. Right? And then 0 times anything is 0, so 0. So lots of ways. But that's good to keep in mind. Is remember, the derivative constant is always 0. So derivative constant is 0. Probably the best way there. What if you have a constant in front of a number? So like, let's get to the one we did earlier, right? X cubed. And let me put a number in front. Let's put like a little 2 right there. So what does that do? Nothing. When you take a derivative, just leave a constant there. Do what we normally do. Bring the 3 down, subtract 1 off. So it's 3x squared. So now you can multiply them. 6x squared. Right? That's the long way of doing it. Really, just if I give you something like this, 3x to the 4th, I just bet you go bring it down, subtract 1 off. So 4 times 3 is 12. X to the 3rd. Man, isn't taking derivative easy when it's power rule? No more limit stuff. Anyway, that's some of the basic ones. Let's go over a few more. The addition rule, very simple rule. Addition or subtraction rule. That basically says this. If I give you a function, let's say 2x squared plus 3x plus 4. Right, now they're all being added. Let's make this negative 4 because it doesn't matter. It can also be subtracted. How do you take the derivative of this? Well, you just take the derivative of each one separately. That's all it says. So derivative of this one, right, bring it down, subtract 1 off. So that's going to be 4x. We haven't talked about this yet. I'm going to talk about it right there. But here's a quick intro. Derivative of this is just 3. Drop the x. I'll talk about it more in a second why. And remember, the derivative constant we talked about this is just 0. So that's my derivative. Right, so that's addition rule. Just if you're adding more than one function, just take the derivative of them all separately. So let's talk about the rule I just talked about. Right, I call it the linear rule. It's kind of weird for most people at first, so I just kind of make it its own rule. That's why you don't see the fancy writing on it. I just made it myself. So let's say I give you y equals 3x. The derivative of that is just 3. And they might say why? Well, remember it's 3x to the first power, right? So you bring the 1 down, subtract 1 off, and look what you get. You get 3x to the 0. Anything to 0 power is this one, so you just get 3. Right, so that's the rule. The rule is if you have y equals kx, the derivative is just going to be k. So keep that in mind. Now there's the one rule I forgot to put on here, so I'm just going to write it in myself, and that's the e to the x rule. How you take the derivative of e to the x. It's actually in your formula sheet. And I forgot to mention that. It should go up. This rule right here is straight from your formula sheet. So the power rule is on there. These rules are not, because they're so simple, like they expect you to know how to do the basic ones. But the power rule is on there. E to the x, which I forgot to copy down, is on there also. And why am I going this over right now? Because the e to the x is the easiest derivative in the world. It's just e to the x. That's all it is. If you want to take the derivative of e to the x, you just copy it down to the exact same thing. Now eventually we'll learn some special ones with the stuff up here, but for now, for the next few videos, e to the x is just e to the x. That's the derivative of e to the x. Okay, so let's do some examples, because that's the best way to learn how to do this. Let's take a derivative with respect to x. So this first one, right, this is my function. Let's take a derivative, bring the 2 down, subtract 1 off. Over here, right, remember this is the rule I just talked about. If it's 3x, you just drop the x. And then there's a minus 5, it just goes away. So that's my derivative. Here's a fancy one. How are we going to do this? Remember last time I said that's not a power rule. There's something inside, you can't do it. So what do we do instead? We distribute. Right, only way to get around this right now is you have to distribute. So I should multiply it out. Remember guys, this is not, please don't make me hurt you. This is not this. Oh, I hate this. Right, it doesn't work that way. There's a minus and a plus there. It doesn't work that way. You have to multiply it out. So if you multiply this out, 5 times 5 is 25. Negative 5x. Negative 5x. Plus x squared. 25 minus 10x. Plus x squared. Now, here's the problem that happens a lot. People are like, oh, did all that stuff? I'm done. You're not done. You just did algebra. Congrats. You did something people could do when they're 12. Right? We're doing calculus here. So we have to take a derivative. Right? So we just did algebra. Let's do some derivative now. Derivative 25 is nothing, right? It's constant, gone. Derivative of this, remember, it's just 1x. That goes away. Negative 10. Derivative of this, bring the 2 down, subtract 1 off. So plus 2x. Right? That's the idea. again, I forgot to add an EX. I'm just gonna add some EX problems randomly, because, you know, math's fun. Let's do this one, e to the x plus 5x plus 1. Right, if I want to derive this, derivative EX is just EX. Derivative that, just 5, and derivative that, it's constant, so it goes away. That's how I take the derivative. Let's do some tougher ones now, because you're like, this is super easy. Oh, it gets a little tougher, a little. So look at this one. Given f of x equals e to the x to the e, sorry. Find derivative and then find f prime of 1. So now a lot of people get freaked out when they see this. F of x is same thing as y. E by itself is a constant, right? That's not e to the x. There's a difference between these two, right? E is just like, it's kind of like pi. E equals 2.71, blah, 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 blah. Pi equals 3.14, blah, 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 right? They're just constants. So you know it looks funky? You treat it the exact same way you treat anything else. You're going to bring the e down and subtract 1 off. So you're going to get this thing, e to the x to e minus 1. That's all that is, right? It's the exact same row as everything else. You bring it down. You bring the e down, subtract 1 off. That's the derivative. Now they want the derivative at 1, just plug 1 in for x. So you're going to get this. E to the 1, e minus 1. Remember, 1 to any power, even this funky e to the minus 1 power, is 1. So it's just 1. My answer is just e. And you thought that was funky. That's just more funky than it is, like, difficult. Let's do some of these. Now, this one right here, right? This is going to be a power, but notice how it's written with square root. In calculus, we never want the square root. We got to rewrite it. So first thing we got to do is rewrite this. Square root is the same thing as x to the 1/2 power. Right, so a little side note here, right? X to the k, let's say m like this. This is always the power, so this part you always write as x to the m. And this is always the root or the denominator. Right, so anytime it's a root, it goes on the bottom, so it goes like this. Right, in this case there's no power, so the power is 1, so that's on top, and then that's the square root is always the power of 2, that goes on the bottom. So you have x to the 1/2, that doesn't look like a 1/2, let me write it a little nicer. There we go, slightly better. Right, now again, I just did algebra, I didn't do any derivatives yet. So next, let's take the derivative. Bring it down, subtract 1 off. So 1/2. Oh yes, you gotta do subtractions. Remember, common denominator. We're not scared, we're doing some calculus now. This shouldn't scare us. Right, so it's 1/2 minus 2 over 2, also known as negative 1/2. And there you go. Now you don't have to clean that up, that's fine. If you want to clean it up, remember, the reason I bring this up is we're going to do it next. You leave it like that, right? I want you to leave it like that. But if you want to clean it up, remember, negative power flips it. Only flips that though, doesn't flip the 1/2, so it'll be like this. And then from there, if you want, you can clean it up and be all like that. Right, so again, you don't have to, especially unless they specifically say simplify, you just leave it like this, but that's how you clean it up. Let's look at the next one. X to the negative 1, next to x to the negative 3 power, just rewrote it. Right, it's a power rule. Bring the 3 down, subtract 1 off. Negative 3x, negative 3 minus 1, that's negative 4. There you go. Again, you don't need to simplify unless they specifically ask. You are done. Now, if they do want you to clean it up, just bring the x to the bottom, right? This flips. So it'll be negative 3 over x to the 4th. Again, it's only if they specifically ask. Sometimes they will. They'll say put in this form, they'll say put in a form like this sometimes. Right, and that just means, okay, I got to make my answer look like this. So in that case, that's what you would do. Let's move on to a few more. Again, we have to rewrite this. Remember the way this works, that goes on top. That's a power, power's on top. And that's a root, so it goes on the bottom. So again, you just rewrote it. Now let's do a little power rule, bring it down, subtract 1 off. 2/3 x, this is 3 over 3. So it's negative 1/3. Again, let's say specifically asked, you're done. Otherwise, you do this. It's a 3. 1 over x to the 1/3. If you want to write that nicer, it'd be like this. That's not much prettier, but whatever. And look at this one. Notice how this one says, so we've been doing a lot of derivatives with respect to x, derivatives with respect to x, derivatives with respect to x. This one's derivatives with respect to k. That doesn't matter because they have a k inside. Just saying, oh, take the derivative of that variable. That's all that means, right? They can change the variable all they want. So it's going to be, bring the 2 down, subtract 1 off. And then negative 3 minus a constant just goes away. And that's how you do it. Oh, let's add another one because I got some space. Let's do an E1. Let's do d of dw of 2e to the w. Right? So remember the way you take derivative of e? Remember, 2 doesn't do anything. 2 is just there. 2 gets multiplied by whatever happens here. Well, derivative of e to w, since respect to w, derivative of e is just e. Done. Look how easy derivatives are of e. Let's do a few more. So right here, another one I'm trying to just mess with you. Right, derivative of this stuff with respect to y, notice they're all y, so it doesn't really matter. So let me write it so we can see a little better. We want to take the derivative of this with respect to y, so we just take derivative like normal. Now this is going to freak people out. Now remember, if you know how to take the derivative of this, you know how to take the derivative of this, right? Derivative of this is just 3, because there's only an x to the first power. Same thing here. So y to the first, that just goes away. So it's just pi. Pi is a constant. Derivative of this one, power rule. Bring it down, subtract 1 off. So minus 3y squared. Now look at this next one here. They want to take the derivative with respect to z. They give you this. So let's maybe rewrite it a little bit so we can talk about it. Now we haven't talked about how to do with the things on the bottom. So what we do not do, you don't take the derivative top and bottom. It doesn't work that way. What we can do with the stuff we have now is you can move this up. Later on we'll learn a rule where you can actually take derivatives of dividing things, but for now all we know is move that up so we get this. And again, I just did algebra. I haven't taken any derivatives yet, so hold your horses. Now you can take a derivative. Bring this down, subtract 1 off. Negative 4z to the negative 3. Again, that's fine unless you want to simplify it, or they ask you to simplify it. But this is fine. Wait, negative 3 I said. Okay, close enough. Okay, this one, right, we talked about this one a little earlier. If I have this, the only way we know how to do it right now is to distribute and then take a derivative. So do some algebra first. 3x squared plus 2x minus 9x minus 6. So 3x squared minus 7x minus 6. Again, I just did some algebra. Let's take a derivative. So now for f prime of x, let's take derivative of each one separately. Right, so this goes down, subtract 1 off, 6x. Derivative of this, right? Remember, it's just an x, it goes away. The x goes away, not the number, sorry. And then derivative of that one's constant. Derivative constant is always 0. So take derivative of that, right? So just distribute and then simplify. Let's go again to some slightly tougher ones. Let's look at this one, right? Remember I talked about earlier, we don't know how to take a derivative when you're dividing yet. So I could flip it up, but honestly, the best way to do this, so we don't mess up, is to separate it. Just some good old algebra. Look at all the algebra we need to do calculus. That's actually where a lot of people mess up. It's not the calculus, it's the algebra. Right, so you can separate it. You can split them up. And then like this simplifies to do x squared. And then this simplifies, right, to be negative 3x. And again, keep in mind, you haven't done any derivatives yet. You haven't brought anything else, subtracted 1 off, right? You just did algebra. So there's still an extra step. So many people just stop because they think that they did some math that they're done. Y prime, take a derivative. 2 down, subtract 1 off. 2x is the first. This has an x to it, so that goes away. Minus 3. Alright, if you understand that one, this next one will be the exact same idea. Right, only difference here in that one is that the bottom thing is a lot uglier. When we talked about earlier, especially in calculus, we don't want radicals. We have to rewrite it to x to the 1/2. And I'm using it the exact same way, it's just a lot uglier. X to the over x to the 1/2 minus 2x squared over x to the 1/2. Right, now I gotta subtract. Remember, algebra subtract is the power 1. You subtract the powers, 1 minus 1/2, it's just gonna be x to the 1/2. 2 minus 1/2. Right, common denominator, you're gonna get 4 over 2. Multiply this by 2 over 2. Minus 1/2, also known as 3/2. Right, so remember, algebra can't be crappy. We gotta be pretty good at algebra here. And again, I didn't take any derivatives yet. Right, don't be all proud you did some algebra. 9-year-olds could do that. Well, in fairness, if you're a 9-year-old Dr. Carter, you can also do calculus. But let's move on. Right, so you can bring this down, 1/2, subtract 1 off. X to the, right, we should be better at this now, negative 2 over 2. So that's a 2 over 2. It's 1 minus 1 is a negative 1/2. And then minus, bring 3 down. Now notice the 2 and 3/2 cancel, so I just get 3. X, subtract 1 off, 1/2. And that's our derivative right there. Okay, one more left. Find dy dx, x equals 1 given this, right? So the problem here is they want me to take a derivative of this, and then at the end we plug in 1. No, we always find the derivative before we plug in the value, right? So before. So we do all the calculus first, and then we just plug it in. So if we want to take rid of this one, again, notice I cannot multiply. I don't know how to do that yet. I do know how to do is distribute. So I get x cubed minus pi x squared. Now let's take a derivative. Right, so y prime is going to be, bring the power down, subtract 1 off, 3x squared. Now remember, the pi is just a number. It could easily be 4 there, or 5. It happens to be pi. So bring the 2 down, subtract 1 off, 2 pi x. Right, so that's my derivative. Now I want it at 1. So it says x equals 1. So you just plug in 1. So it's going to be 3 1 squared minus 2 pi times 1, which is going to be 3 minus 2 pi. And that's the answer. There we go. We're done.